Okay. Activity 4, Lab 4. All we do for this one is fill out this chart accordingly. So, bonding pair, hydrogen and hydrogen, is going to give us an electronegativity difference of 0, which gives us a nonpolar covalent bond type. And then B and F is 2 minus 4 is 2. GE and F is 1.8 and 4 gives us 2.2. C and H, 2.5 minus 2.1 equals 0.4. N and H is 3 minus 2.1 equals 0.9. H and O, 3.5 and 2.1 that equals 1.4. P and Cl, 2.1 and 3 is 0.9. S and F, where's S? 2.5 and 4 equals 1.5. Xe and F, 2.6 and 4 equals 1.4. O and O gives us electronegativity of 0. C and O is 2.5 and 3.5, so that gives us 1. C and F is 2.5 and 4, which is 1.5. 1.8 is Sn. Chlorine is 3. 1.8 minus 3 is 1.2. Al and O, 1.5 and 3.5. That gives us 2. Na is 0.9. Nitrogen is 3. Equals 2.1. And G is 1.2 minus O is 3.5. It's 2.3. Mg and Cl is 3 and 1.2. Subtract those, you get 1.8. And based on this electronegativity difference bonding scale chart, H and H is nonpolar, covalent, like we said. B and F are ionic. GE and F is ionic. C and H is polar covalent. N and H is polar covalent as well. H and O is polar covalent. P and Cl is polar covalent. S and F is polar covalent. Xe and F is polar covalent. O and O is nonpolar covalent. C and O is polar covalent. C and F is polar covalent. SN and Cl is polar covalent. Al and O is ionic. Na and Cl is ionic. Mg and O is ionic. And Mg and Cl is ionic as well. Alright. Bond polarity. Just draw a vector between the polar covalent bond types. And you draw the arrow pointing towards the one that has the most electron activity. There you have it, activity 4. Now I'm going to go do that for my compounds, and then we'll be on to activity 5.